All right, hello AP Pre-Calc students. My name is Mr. Bear, and I am going to present to you a video for how to complete the FRQ on your study guide for the Unit 2.2 to 2.6 test. All right, so it says here, the price of a 30-second ad during the Super Bowl can be modeled by an exponential equation in the form of P of T equals A times B to the power of T minus 4, okay? I'm gonna rewrite that a little bit nicer here. The PDF really didn't make this look very good. So that's the format that our equation is gonna be in. It says T represents the number of years since 1975. So think of 1975 as year 0, okay? P of T is going to be the cost of the ad in thousands of dollars. All right, so they give us two specific scenarios here, and part A, item 1, says to use the given data to write two equations that can be used to find the values for constants A and B. All right, so my first one, I'm going to use this information, and my output is 2800. So 2800 equals A times B to the 4 minus 4. All right, if you wanted to simplify that to 2800 equals A times B to the 0, that is fine. And that further simplifies to just 2800 equals A. All right, for the second data value, we're going to have 5700 equals A times B to the 25 minus 4. You could have written that as 5700 equals A times B to the 21st. That would be okay. All right, for part B, or part 2, item 2 of part A, rather, it says find the values of A and B as decimal approximations. Okay, for this one, we're going to have to do a custom regression on Desmos. Okay, so let me show you how to do this, okay? All right, so I'm going to navigate between my screen here, and here is my College Board Desmos. Make sure that you are on the College Board version. We're going to add a table, and short-term memory loss is real. My data values are 4, 2800. So when x1 is 4, I have 2800. And then for 25, I have 5700. Okay. All right, there's my data. I'm going to hit the little magnifying glass here to just show me where those are. And we're going to initially run an exponential regression, but remember, this is not our A and B values, okay? Our regression equation, according to this, says something times something to the power of x. Well, if we look at our equation format, our equation format says it needs to look like this. So I need to do a custom regression so that I can make that exponent say t minus 4, or x minus 4 is what I'm going to do. All right, so what I'm going to do is I'm going to click these 3 little dots next to where it says exponential regression, so right there. And I'm going to export as custom regression. Okay, and then what I'm going to do is I'm going to go up to my exponent. I found that I needed to put a parentheses around this. I'm going to put my x minus 4 like so. And now that I have done that, I now have my equation with the A value is 2800 and the B value is 1.03443. So I'm going to go back to my study guide and I'm going to say A equals 2800 and B is, what did I say that was again? Well, there we go. It was 1.03443. Okay. All right. So now what I'm going to do is I'm going to answer part B, items 1 and 2. To do this, I'm going to store that equation into my Desmos here. So I'm going to store this as P of T, because that's what it said this function was. Easier on a keyboard to do this. And I'm going to put my A value, which is 2,800, and then times my B value, which we had 1.03443, to the power of, and then in parentheses, I'll put t minus 4. Okay. And there's our equation, which now I can get rid of that. And honestly, I can get rid of that as well. Okay. So now, question B1 says, find the average rate of change from t equals 5 to t equals 10. So what I want to do on my calculator is I want to do P of 10 minus P of 5 over 10 minus 5. I'm going to call that M to represent my slope. So I'm going to go here and I'm going to type that in. M equals, set up a fraction. I'm going to do P of 10 minus P of 5 over 10 minus 5. And my output, according to the calculator here, says 106.830655416. I'm just going to round that off to 3 decimal places. So 106.831. Okay, so 106.831. That's our average rate of change. It says show the computation that's lead to your answer. So I did that and I showed my answer. All right, part 2 says consider the average rate of change from t equals 10 to t equals m, where m is greater than 10. Are these average rates of change greater than or less than the average rates of change that you found in part 1, which was from t equals 5 to t equals 10? Okay, so what I'm going to do is I'm going to go back and look at this graph, okay? And when I look at this graph, I can see that when t equals 5, that was about here. T equals 10 is about right here. So there's my slope there. And then for values that are larger than 10, if you look at this graph, you should notice that this graph is a concave up graph, okay? So what I'm going to do is just roughly sketch this on my notes here, or on my sheet here, okay? So I've got my X and Y axis, and it's roughly concave, or it's roughly looking like this. So here's where t equals 5, here's where t equals 10, and m is some value bigger than 10. And what they're asking is the average rate of change from 5 to 10 greater than or less than the average rate of change from 10 to whatever our m is? Well, since P of t is concave up, the average rates of change are increasing. My handwriting is awful, I'm so sorry. So the average rates of change are increasing. Since t equals 5 to t equals 10 is less than t equals 10 to t equals m, the rate of change between t equals 5 and t equals 10 is less. Or actually, I'm saying that backwards. So we want to talk about the rate of change from the rate of change from t equals 10 to t equals m is greater. Okay. Part 3 asks you to write the equation of the secant line that passes through these 2 points. And here's your formula. All right, we've already done the All right, actually, we're going to find the average rate of change. So your M is going to be 5,700 minus 2,800 divided by 25 minus 4. And we're going to use our calculator for that. Actually, I can just use a basic calculator for this. So I'm just going to do, let's see, what was that? 5,700 minus, what was it? Sorry, 5,700 minus 2,800 over 25 minus 4. The actual average rate of change is 138.095. So what I'm going to do is I'm going to now call that, my M, okay? All right. And then what we'll do is for my T1, I'm going to pick this first order pair that we have. So I'm going to do 2,800 plus my M times T minus 4. Okay. And the way that that equation will look is it'll be 2,800 plus, let's see, what did we get when I did that as M earlier? 138.095. Sorry. Times T minus 4. Okay. There is your equation. Okay. Part 2 says, is the secant line an overestimate or an underestimate for the data? Okay, so if I were to look at my graph and I were to look at the secant line that goes through t equals 4 and t equals, what was that, 25? If I look here, if I were to connect those points with a secant line, that means that my secant line is above the curve, so the secant line is an overestimate of the given data. Okay? And the reason for that is because your secant line is intersecting a concave up curve. So it intersects a concave up curve. What that means is the average rates of change on the curve are increasing. So that's why initially in this interval, the line that we drew is an overestimate. But as we were to move further along the curve, the average rates of change on the curve are increasing. Okay. Last one here, it says, should the company be more confident in the model's prediction for t equals 12 or t equals 42? Well, t equals 12 is within the data range given. And because of that, that means I would trust this value. And the reason I would do that is because we know what's going to happen all the way up to t equals 25. We know that this model works at least up to there. All right, now this is an exponential model, but there might be a point where the data no longer is exponential. Maybe it starts to level off, and that could happen out here somewhere. And so we don't know what's going on here at t equals 42. So we don't want to trust that data value. It's outside of the scope of the data that was provided to us. Okay, so we're going to trust the data that is, or the data value which is within the data that was provided to us. All right, happy studying.